Don't miss this year's Commercial UAV Expo, September 2nd to the 4th in Las Vegas. It's the premier event for the commercial UAS community, focusing this year on drones in action. Use code SAVE100 for a $100 discount or a free Expo Pass. For more information, go to expouav.com.
We build modular hardware that's always appropriate for the threat of the day. It uses modular software also to keep costs low. And by keeping everything modular, open standards style approach to development, we make sure that we can evolve just as fast as the threat's evolving.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 446. What role will autonomous targeting systems play in future battlefields? For this question, we head to Littleton, Colorado, to speak with Bryan Bockmon, CEO of AimLock, a company pushing the boundaries of defense autonomy with real-world solutions that enhance mission effectiveness and save lives. Founded in 2013, AimLock is a U.S.-based developer of advanced autonomous targeting and engagement systems for defense applications. Their core targeting modules are designed to deliver decision-accelerating autonomy across a wide range of mission sets, including Counter-UAS, force protection, direct action, and more. With a fully networked modular open systems approach, or MOSA for short, AimLock's technology integrates with everything from small arms to unmanned systems, aircraft, and maritime platforms. Bryan brings more than 2 decades of experience in research and development, engineering, and leadership across autonomy and weapons systems. At AimLock, he leads strategic initiatives and product development with a focus on scalable battlefield autonomy. He's a strong advocate for integrating autonomy into defense operations and is especially passionate about how small businesses are helping redefine the future of warfare, particularly in the wake of the global war on terror. Under his leadership, AimLock is setting new standards for modular design and rapid field deployment. In this episode of the Drone Radio Show, Bryan shares insights on AimLock's innovations, including the role of core targeting modules, how MOSA is transforming defense integration, and what the future holds for autonomy in the combat space. We'll also explore how AimLock supports platforms across air, ground, and maritime domains, and how lessons from real-world conflicts like Ukraine are influencing system design and deployment. But before we hear from Bryan, I want to stress that your support is the heartbeat of my podcast. Every episode is crafted with you in mind, and your generous donations ensure I can keep delivering the content you love. Whether it's a price of a coffee or a more substantial contribution, every bit helps to defray the cost of production. Donate today and be a vital part of the podcast's continued journey to greatness. To donate, go to droneradioshow.com/donate. And if you can, please subscribe to the podcast on your favorite platform and leave a nice review. It really helps improve the podcast ranking among the many thousands of active podcasts today. And by the way, if you have a great story on the use of drones that you'd like to share on a podcast, contact me at randy@droneradioshow.com. So let's learn how autonomous targeting systems are used in the battlefield with Bryan Bockmon of AimLock. Let's pick up the interview where I asked Bryan to introduce himself.
Yeah, my name is Bryan Bockman. I'm the CEO and founder of AimLock. We're an autonomous weapons integration company.
Bryan, let's start with the basics. Tell us about AimLock. What does the company do?
Anytime you're dealing with autonomous systems, there's a conversation about where on the spectrum from fully automated to fully manual do you stand. And the easiest way to provide context for that is basically to tie it back to autonomous vehicles. Fully autonomous systems, you have the machine automation is handling every part of the driving experience, from navigating to emergency handling, and that's considered fully autonomous. You can contrast that to fully manual, where the human driver is doing all that. In between, there are all kinds of systems that can aid a human become a better driver. Traction control systems and automatic braking systems and cruise control and lane holding. These represent the transitional state from fully manual to fully automated. And AimLock does the same thing for military clients who are looking to transition from fully manual weapons deployment up toward scaled machine control systems that help us to become more effective at executing those military missions.
What vehicles does AimLock support? Are you focused solely on drones, or do you also work with ground, maritime, or other platforms?
Yeah, we do all of the above. When I say that we focus on weapons autonomy, what I mean is that the weapons integration is usually involved with utilizing sensors to find threats that need to be engaged, and then preparing the force effect that may be involved. So most people are familiar with gun systems, missile systems, rocket systems. You may even be familiar with directed energy, like laser and high power microwave. All of those are military force effects, and a good autonomy kit can make sure that it's using the sensors to the best effect, and then it's delivering those kinetic effects or energy effects in the maximum possible manner.
Let's zero in on the drones. How does your product fit into the broader UAS ecosystem?
All drone systems either have to be remotely controlled by a pilot, or they need to have automation systems on board that can manage part of the mission. That mission usually involves navigating from one place to another, and navigation is easily managed by GPS system, global positioning systems. It can also be managed by visual navigation systems. So this is think of a computing system that's riding along on a drone. It carries with it a stored set of maps. And then as it flies, it can compare the imagery that it's seeing from any cameras that may be on board back to those maps in order to create a match between the two. And as it creates a match, that is used as a navigational tool. And that kind of navigation is automated visual navigation. So AimLock builds computing systems that are specialized for unmanned systems. And in this case, if we provide a visual navigation software package that gets the drone from point A to point B without being dependent upon other assets that might be denied by an adversary. GPS is really commonly jammed or spoofed. So that's stage one. Stage two involves locating the targets that are supposed to be assessed for engagement. So usually there are cameras, sometimes there's radar and other sensor suites that may be carried on board the drone. An autonomy kit can process the information that's coming from those sensors and provide assistance to a human operator that's remote by saying, hey, I, the autonomy computer, have looked at all of these sensors. I've found the target that matches the criteria that we're searching for today. And in that particular case, it just notifies the human operator that that part of the mission has been conducted, and now we can make some sort of decision about the engagement. And then the final stage is make the weapons ready. That involves transitioning from a safe state to an armed state. And then once things are armed, the weapons can be released and directed to the intended target.
So in that third phase, drones actually carry weapons.
Yep, that's absolutely right. You don't have to have all of these on the same asset, but it's one particular way to create a mission capability.
Can you describe the look and feel of the drones? Are they more like the traditional high-altitude Predator drones? Or are they closer to the modified commercial drones we see in Ukraine?
Drones come in all shapes and sizes, and the reason for that is because there are many types of missions that have to be completed. And the small FPV drones that are used in Ukraine right now, they're affordable to produce. So if you lose this asset in combat or in training, it's not a major impact to your budget. But Currently, they still require a significantly well-trained force to operate them. And so the size, the weight, the cost, and the abilities, and then their effectiveness at teaming with human operators, all those create one data point in the spectrum of drones. The Predator is obviously the one of the far opposite ends of the spectrum, where many things are automated, many of the systems are exquisite, single purpose mission, legacy weapon systems and ISR, intelligence, surveillance, reconnaissance type assets as well. In between, you see all types of helicopters, from multi-rotors, which are very practical, small, affordable, and easy to operate, to single rotor and dual rotor, high efficiency helicopters. Those have a particular space in the mission spectrum. They can fly longer than multi-rotors can, and they cost a bit more too, but they don't require full manual operation the way that FPV drones do. And then after you exit the vertical takeoff drone regime and you switch over to fixed wing, there's also a family of fixed wings that go from small to large, from simple to complicated. And what we usually try to do is aid our user groups in selecting the asset that serves their mission the best.
Do you manufacture the vehicles, or do you help your clients integrate your systems into drones that they already have?
It's all of the above. The most common circumstance is that there is a drone manufacturer somewhere in our ecosystem that's making a perfectly well-suited drone. And we can purchase those drones and then integrate them into a mission system using the services that we offer. That works out really well. Occasionally, you'll find some special mission that requires a capability that doesn't exist, and then we either build that capability or we aid other people in building that.
I understand that AimLock started working on Counter-UAS technology back in 2018, just as that space was heating up. What were some of the early challenges you faced gaining traction? And how have recent developments in electronic warfare changed your design approach or the urgency of the solutions?
We built technology from 2012 to 2018 that we knew was going to be useful in many different forms. And it's sort of the job of every small startup to figure out which markets require that solution early and which markets may not need it until way later. So that process usually involves building a prototype and then testing it against the mission set. So we did that early, you're right. And in that time frame, there were many, many people who were involved in making mission decisions and acquisition decisions who knew that we needed to build electronic warfare style defenses first. And some of them even surmised that we may be so successful with electronic warfare that we never have to return back to kinetic defensive systems, anti-aircraft guns, etc. And from 2018 until 2022, there was a strong focus on electronic warfare defense layers. But yeah, the invasion in Ukraine, even conflicts in Armenia, Azerbaijan, revealed that electronic warfare is not capable of adapting quickly enough to adapt with the threat landscape. And so a fully featured counter-drone system is going to involve layers of electronic warfare and layers of kinetic defensive systems as well. These might be missiles and rockets, which are interceptor style. And then they finally end with gun systems, which are your last line of defense against any threat that's approaching you.
Given how quickly drone and counter-drone technology evolves, how do you stay nimble?
What we see, and many other companies see this too, is it's completely unaffordable to make large investments in hardware that is difficult to change. So we build modular hardware that's always appropriate for the threat of the day. It uses modular software also to keep costs low. And then, software can sometimes iterate on a weekly basis. Hardware now is iterating on 3-month cycles, 6-month cycles, like we've never seen before. And by keeping everything modular, open standards style approach to development, we make sure that we can evolve just as fast as the threat's evolving.
I read where AimLock's Autonomy is specialized for weapons integration. Can you walk us through what that means in practice and how it works?
Yeah, let me contrast it first with vehicle autonomy. Whenever an autonomous system, computing system, is running software to drive, there's a particular time scale that it has to operate on. It has to be able to react quickly to emergencies so it can stop. But when it's navigating, the vehicles are traveling rather slowly. And so the autonomy kits can run rather slowly. That affords those developers a chance to use commercial off-the-shelf computing. And sometimes they can use commercially available software as well. And it functions in a timely state so that it can drive the vehicle. Weapons integration is not always like that. Many times the weapons are traveling very fast. Bullets obviously travel fast. Missiles travel quickly. And these sensors have to operate more quickly. All of the software algorithms have to operate more quickly. Many, many, many things are safety critical. And so that generates specific performance requirements for the engineers. And not all autonomy can function in that time frame. So AimLock's autonomy is specialized to be quick, be precise, and be safe.
And it can function with all the different mission sets and payloads that you mentioned?
Yeah, it's always a strange blend of sensors and robotics and effectors that create these mission kits. But that's right. Our autonomy modules can connect to legacy sensors. So even if they're very old, if we've invested significantly in them, they can still play a useful part in today's mission.
When the systems are deployed in the field, how do military planners put together the mission pack? What goes into deciding how the drones will be configured for a particular operation?
Yeah, I can't claim to know everything that they're planning right now. Most of the mission ConOps are classified anyway. So my impression generally is that many, many, many smart people who have significant combat experience are reinventing fighting doctrine right now away from manned systems where we have to put one of our warfighters directly near the threat, all the way over to unmanned style warfare. So remote controlling with partial autonomy is now a part of every warfighting plan that I know of.
How does AimLock's modular design approach fit within DoD's procurement process? Does it make acquisition and integration easier or more complex?
Primarily, it's breaking down a lot of obstacles that prevented us from doing rapid acquisition in the past. A good example might be that a weapon system has to go through many tests to be qualified as safe to deploy for our warfighters because we don't want to introduce any unnecessary risk into their job set. And that mandatory safety testing can slow down the deployment of a new capability by years if you wanted to bring a new weapon to bear. So by using a modular autonomy controller and a legacy weapon system, now you can take advantage of rapid acquisition tools in the same way that you would be using the new software acquisition strategy to rapidly test and then obsolete software as you find necessary for your mission set. You can now use that strategy and still gain access to your legacy weapons portfolio because there's an appropriate piece of hardware and software standing in between the two worlds.
Have any of your systems been deployed operationally? And if so, are there any results or lessons learned that you're able to share?
Predominantly, we're not made aware of combat use of the equipment. However, I will say that any new equipment that's being adopted into a program goes through a readiness level check. And so that creates a common standard language for everyone to use. And once a piece of equipment has been assessed as combat ready, it's called TRL8, Technical Readiness Level 8. And that means that real military end users have assessed the equipment by using it in a simulated combat environment, and they found it to be acceptable. So yes, while we do continuous research and development all the time, we have already matured some systems into that combat deployment state. And so it's ready to be used anytime it's needed.
I'm sure you've been following the use of drones in Ukraine. What has that conflict taught you about the real-world performance and evolution of drone-based weapon systems?
I think there are many opinions that all of us have derived from observing this conflict. The one that this is not an original concept, but I've heard other commentators pinpoint this. They say that Ukraine's use of FPV drones to project force forward to the front lines was obviously novel, and under great pressure, they innovated quickly and delivered a new kind of capability that was combat effective. What they've noted is that there are circumstances where it's highly cost effective and risk effective to use FPVs to deliver kinetic effects to the theater. There are other circumstances where they're not appropriate, right? And so conventional Long-range precision fires are still necessary for any kind of large-scale combat operation. It'd probably be inappropriate for any of us to surmise that there's such a thing as a silver bullet that's going to be very cheap, easy to deploy, easy to train, and it's going to solve all of our problems. So my biggest takeaway is a family of systems is always going to be necessary in order to make our nation ready for large-scale combat operations. And honestly, for irregular warfare, families of systems are often appropriate. So we find it really cost-effective to repurpose these modules across the entire family. And now the costs are disaggregated across all of those different program areas.
We haven't seen rogue drone attacks at scale yet. From your perspective, is that because the technology is still too complex for bad actors? Or is there something else preventing that kind of threat from materializing?
I'd have to surmise that it's not a technological hurdle and it's not a financial hurdle at this stage in development. I think, honestly, it's a strategic play. Whenever any particular party escalates combat, they know that it's going to draw attention. And so there are certain circumstances where it's appropriate to escalate force and create conflict. And then there are other circumstances where it would be wise strategically just to hold back on the things that you could do because it could trigger a response.
In your view, what sets AimLock's counter-drone approach apart from other systems currently being used or discussed in the market?
I think our best advantages relates to bringing 2 decades of technical development experience to this new perspective of modularity. I've got a long scientific research background. All of the founders do. Most of our staff does as well. So we have the ability to foresee integration difficulties that many companies are not familiar with yet. So that allows us to collaborate with end users, with government acquisition officials who wish to really rapidly break through all of the obstacles that would prevent us from deploying high effectiveness systems. So we can talk about architecture. We can talk about specific hardware. We can talk about acquisition strategy. We can talk about compliance with safety regulations and security regulations and export regulations. And that breadth of experience dramatically reduces the time scale needed to deploy new solutions. And right now, deploying quickly is cost effective and it's low risk, and everyone knows that we need to be ready as quickly as we can.
I came across the reference to visual-based autonomy in materials on the website. What exactly is that?
Yeah, I alluded to it earlier and didn't expand completely, but every autonomous system needs to perceive its environment. Sometimes this is done through RF data links. GPS is all RF data links with the satellites, which are emitting timing signals. Visual-based autonomy uses computers, onboard computers, to interpret the surroundings. So we're not relying upon RF signals to do so. We're doing terrain matching. That's one type of visual-based autonomy. Beyond that, we apply a technique called aided target recognition. This is a computing system matching the profile of targets that it sees in a live video feed to the profile that was saved in a model previously. Then it cascades through an entire set of other algorithms that aid the interpretation of that video feed. That's what allows the computing system, the autonomy computer, to create visual automated algorithms that are reliable.
Does visual-based autonomy come into play in GPS-denied environments?
Absolutely. Like any kind of large-scale combat operation or operations that may be in a near proximity to a critical asset are going to have almost no chance of perpetual data link back to a remote operator. And they may not have any chance of using other RF direction finding or navigation assets as well. So being able to, the system having an inherent capability to complete its mission without access to remote signals is an imperative of the future.
And is the drone also able to complete its mission autonomously if contact with the pilot is lost?
There's a really good case study involved with legacy cruise missiles, which have for many years contained the right kind of autonomy to know where they are, where they're headed, and what they should do when they arrive on target. And so the case precedent is appropriate. The legal studies have been done. Most commanders understand what type of risk assessment that they're responsible for making as they make an engagement decision in that scenario. And then there are technical tools that they have available to terminate the mission, wave off, send the weapons to a different place. And all of those go into their policy and their tactical decision making.
Looking at where your technology is today and where it's headed, how do you see it shaping the next generation of warfighter tools?
What we chose to do is make sure that the warfighters had access to tools that can rapidly adapt to what they see. You may not have time to develop new hardware in response to a threat you see on the battlefield, but if you had the appropriate hardware and software in your toolkit, when you see that change happen on the battlefield, you can react immediately.
Do the warfighters using your systems need specialized training to adapt? Or are the systems designed to be intuitive for operators who may be familiar with a broad range of technologies?
No, there's definitely groups of people who are gifted at using this new generation of machines. Many military occupational specialties have involved using high-tech equipment for many, many decades. And so those people are already well equipped. They have the right mindset, they have the right education, the right tools to adapt to a new generation of autonomy. And I think that there are even more specialty areas that are going to be created and blended into the squad structure in the future. That way, every unit can have at least one specialist, the same way that they have communication specialists and particular weapon specialists.
Is AimLock's focus exclusively on the military market? Or have there been inquiries or applications from civilian or commercial sectors, either here or internationally?
The weapons integration services and products right now are restricted to military and law enforcement, but the technology stack itself has an almost infinite reach of applicability. So in future years, you'll see more and more of this defense technology bleed over into the commercial market and provide enhanced safety and security to all types of commercial purposes.
What's next for AimLock? What should we be watching for in the coming months?
Well, you'll see that we're maturing even more of our systems into that combat ready state. One system is already combat ready and deployable. There'll be 3 more that come in the next few months. For all of the remote weapon stations that are useful for unmanned systems and for counter unmanned systems will be matured up to that rate. It's likely in the next 18 months. Then after that, there'll be continuous new product development as we attack further and further mission priorities that are important to our end users.
Are there any new modules or product lines on the horizon that you can share with us?
We have a small remote weapon station that is optimized for mounting on unmanned aerial systems. We call that the RS-1. So it carries conventional rifles and grenade launchers that you would see an infantry member carry, and it allows them to remote control the location of the deployment of this effect. So if they already have medium-sized multi-rotor drones, then we can integrate this weapon system in immediately, and now they have a remote control weapons capability. This is great for sniper overwatch when the squad is too small to have helicopter assets or close air support from fixed wing. Now they can function much of their mortar mission and their close air support mission within their own small unit. Then soon the medium machine gun weapon stations, our RM1 product, will be found on small vehicles, on small surface boats, all of which need the automation to provide a counter-UAS mission, because even a conventional machine gun can give you an effective 200 or 300 meter standoff of protection against small drone threats. And they'll also be used in the conventional missions, so counter personnel, counter vehicle style engagements. After that, we'll be releasing an autonomy package for large weapon stations. These are the specialized 30 millimeter cannon, 25 millimeter cannons, and larger, which have munitions that are proximity fused. This is really effective for anti-aircraft, counter-UAS. Those are the next ones to come up to the maturity level.
When deploying your systems, do you also account for protecting them with your own counter-UAS capabilities? Essentially, defending your assets from other drones?
Sure. It's a constant battle internally. We may even have to create teams inside the office so that they can discuss countermeasures and countermeasures for everything.
Is there anything that we missed that we should talk about?
I think the only thing relevant here is some really exciting developments in acquisition reform. So we see the legacy weapon system acquisitions not being able to react quickly enough to the current threat. They'll still provide those strategic level assets that the nation's always going to need. On the other hand, some solutions like software solutions can be commercially competitive. There's a huge commercial market for software. It can be reapplied to the defense market, and that is a completely different type of acquisition. In between these two extremes, we have a blend where there's a specialized need that only the military has, and they need to find a new way to procure that and collaborate with industry and academia to make sure it gets ready quickly enough. If we only look at it through a lens of commercial off the shelf and exquisite government design systems with a requirements stack, then we're going to miss out on all of the opportunity to act quickly that we could have if we had a hybrid solution in the middle.
And for my final question, Bryan, what message would you like to leave regarding the future of the drone industry?
I think the one message that's the most important to me right now is that there is now an opportunity for all types of engineers and technicians to aid our nation in contributing to this mission of strategic security in a way that I've never seen before. And I'm really excited to see the innovation that comes from small business, from medium business. I'm excited to see all of the new innovation at trade shows and on the battlefield soon.
That's it for episode 446 of the Drone Radio Show. I hope you enjoyed hearing from Bryan Bockmon of AimLock. I want to thank Bryan for taking the time to speak with me. If you want to learn more about AimLock or want to connect with Bryan, check out the webpage at aim-lock.com. If you like the Drone Radio Show, then please subscribe and share. Write a glowing review. And if you're able, donate to keep the podcast going. Go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.